Good morning, everyone. Welcome back to my channel. My name is Arijit, and this is our fifth session related to SCM Analytics. So let me share my screen. Okay, I hope that you are able to see my Excel file. So in our last session, we solved one transportation issue. First of all, by creating this mathematical model from the English language, and then we resolve this issue by using the Excel solver, right? And uh, these distribution centers are the sources and these customers are the destinations. Okay, so this was also we discussed in our previous session. Now we have denoted this cell as X11, this cell as a X uh, 12, this is X13, and this is X14. Now, how we have denoted this cell as X11? We have denoted this cell as X11. Now, this one is from the source, that is distribution center 1, and this one is from the destination, that is customer 1. Okay, so this cell, likewise, we can refer as X12, right? So 1 comes from the source, 2 comes from the destination, that is the customer 2. By this way, we have modeled this mathematical formula, right? So now you can see for this small problem also how big the formula is, right? So today we are going to see how to formulate the mathematical model in a more compact way. Okay. So let me go to the whiteboard. Okay, so this was the mathematical model which we discussed in our earlier session. So you can see for the demand constraint, this is the big formula that we have written. This is for the supply constraint mathematical model, and mean z, that is our objective function. Okay, so if we want to formulate this mathematical model in a more compact way, then how we can do that? Okay, so we are going to start from the demand constraint. For the demand constraint, you can see x11, x21, and x31. So first one is coming from where? First one is the source. Okay, and the second one, that is the destination. For here, x21, 2 is coming from the source and 1 is coming from the destination. Okay, so x21 means which cell? X21 is this one, distribution center 2 and customer 1, right? X31. So again, 3 comes from where? 3 is coming from the distribution center 3, and 1 is what? 1 is the customer 1. Okay, so 3 is the source, 1 is the destination. So if you can see here, the source is changing, but your destination remains constant. So here you can see x11, x21, x31. That is, destination is constant, which is 1. Right? But the source is changing from 1 to 2 to 3. Similarly, from here also you can see the source is changing from 1 to 2 to 3, but the destination remains constant, that is 2. For this one also, the source changing from 1 to 2 to 3, but your destination is 3, which is constant. This is the destination, this is constant. This is the destination, which is constant. Okay. So here we can write Here we can write for demand constant summation, because anyways we are doing the sum, right? Here you can see the addition signature. So this is summation. Now what is changing? Our source is changing. Okay, before that, let me write it down. I equals to source. Okay. And j equals to destination. Okay. So here, as we discussed, our source is changing, but the destination remains the same. Okay, so here we can mention I equals to 1, because I started from 1 only, x1, x1, 2, x1, 3, x1, 4. So I that is the source started from 1. And what is the maximum value of the source? The maximum value of the source is 3. This is the one, the maximum value. Okay. So here we can write the maximum value of 3 is the maximum value of source is 3. Okay. Now what is xij? That's the quantity. So I is the source and j is the destination. In our last classes, we have mentioned that that these cells we have referred as a xij, right? So x11 means what? This 11 means what? The distribution center one and the customer one. That means xij. I is the source, j is the destination. Okay. So summation of what? Summation of xij. Summation of xij. Okay. Should be equal to what? Should be equal to dj. Now what is dj? What is dj? Demand at j market. So these are nothing but the demand. These are nothing but the demand of that market, right? So this is look, see, these are just nothing but the notations. Okay. So these are helping us to formulate a more compact mathematical model. So instead of DJ, you can also mention something like AJ, BJ, whatever you like. Okay. So DJ is nothing but what? Demand at the jth market. Demand at the jth market. Okay. And this formula is applicable for all these cells, means not only for x11 x plus x21 plus 31, but this formula is also applicable for x12 plus x22 plus x32. That means this formula is applicable for all the jth market, for all the destination. Okay. Now, how to apply this formula for all the destination from x11 plus x21 plus x31 to x14, x24 plus x34? To do that, to apply this formula for all the jth market, what we need to write? We need to write this formula. Now, what is the meaning of this formula? This is for all. For all. Okay. And what is this? This is nothing but the summation or addition, whatever you want, you can take. Summation or addition. Okay. So to apply this formula for all the jth market, that is the destination, we need to write for all j set of capital J. Now, what is set? This is set. This is set. Okay, now what is this? J set of small j set of capital J. Now, the value of small j is 1 or 2 or 3 or 4. Now you can see that this is 1, the value of j, this is 2, this is 3, and this is 4. So this is the index of the destination, small j. Okay. Now what is capital J? Capital J is the set of small j. That means capital J consists these values. Okay. So big J is nothing but the set of small j. Now see, this is our mathematical formula for the demand constraint, and you can see the difference now. Here, we had to write around 4 statements to define the demand constraint, but here, only with a single line, we can able to demonstrate the mathematical model for the demand. Okay, so likewise, we are going to create what? Likewise, we are going to create compact mathematical model was supply constraint. Okay, in our last session, this was the supply mathematical model which we created from the English language. Now today we are going to create a compact mathematical model. So here we have mentioned x11 plus x12 plus x13 plus x14. Okay, so which is the x11? This is the x11 distribution center 1 and the customer 1, and that is why we have referred this cell as a x11 plus x12. X12 is what? Distribution center 1, customer 2. X13 distribution center 1, customer 3, and x14 distribution center 1 and customer 4. Now what is distribution center 1? That is the source. What is customer 4? That is the destination. Okay, so here also whatever we have mentioned while constructing the demand constraint, I equal to source, j equal to destination, right? So here also you can see here the source remains the constant x11, x12, x13, x14. The source remains constant, but what is changing? Our destination is changing. The destination here is 1, this is 2, this is 3, and this is 4. And we are doing a summation, right? So that means here we can write, first of all, summation. Okay. So here you can write, first of all, summation. Okay. Then J is changing. J means what? Our destination is changing. So our destination started from 1. Here you can see our destination started from 1. Okay. And what is the maximum value of destination? That is 4. So here we can mention as a 4. Okay. Again, Xij. Okay. So we have mentioned the same thing for demand constant also. You can see here Xij. Okay. Then what should be less than equal to, should be less than equal to Xi. What is Xi? What is Xi? Xi equals to capacity of source so we have denoted the capacity of source as xy to formulate the mathematical model here, right? So these are nothing but the capacity of source. Okay. Now to this is semicolon. Now to apply this formula for all the sources. That means this one, this one, this one. What we need to write? Again, we need to write this thing for all I set of capital I. So here capital I is a set of small I which consists the value 1, 2, and 3. Okay. So this is 1, this is 1, it's 2, and 3. So this is the formula of our supply constraint. Look, see, after formulating the mathematical model, we can able to reduce 3 lines into a single line. Okay. Now we are going to see how to formulate the objective function in a more compact way. We are going to use the same logic what we did as of now. Okay, this was the objective function which we discussed in our earlier session. Now here you can see x11, x12, x13. Now what are the which cell is this? X11, x12. This is x11. This is x12, x13, x14. Okay, so we have done like this way. Now how to formulate this one? So let us formulate the mathematical model in a more compact way. So what we can write? Mean Z mean Z equal to summation, as because we are doing the addition only. Okay. Now what is the maximum value of the I? Maximum value of the I is 1, 2, 3, because we have only 3 sources. Okay, so that means we can write here I equals to 1 and this is 3. Okay. We need to write another summation for the destination. Now, how many destinations we have? In our problem, we have 4 destinations. That means here we can write J starting from 1. J started from 1 and maximum is 4. Right? Now, Cij. What is Cij? So we have referred cost per unit. Okay, so CIG is what? Cost per unit. That means this is a CIJ, this is CIJ, cost per unit. Okay, and then again XIJ. XIJ is what? This is the XIJ. I is the source and J is the destination. I is the source and J is the destination. I is the source and J is the destination. Okay. Now see, we have formulated the mathematical model for objective function in a more compact way. All right, so that is the end of our today's session. I hope that you have enjoyed the class. And today we saw how to formulate the mathematical model in a more compact way. So in our next classes, we will solve some more problems so that we can understand the concept first of all before moving forward with some more complex areas. Okay, so that's the end. And so yeah, see you in the next class.